Okay, I have two examples here I want to show you in terms of area of regular polygons. The first example is more about finding measures of the angles, and that's really important because later on we're going to need to use some trigonometry to find out some of these areas. This one we will not have to. So right off the bat, we have a pentagon here. And the question is, what are the measures of these angles? And I think the most important angle in here is the angle 2. That's the one I will be finding. Well, I'll find them all, but we can find angle 2. We'll stress that one a little bit more, how to find that one. First of all, if you look, there are 5 sides. This is a pentagon. And there are 5 triangles. So all I need to do is understand that if I were to go all the way around this center, there would be 360 degrees there. So to find the measure of angle 1, I would simply do 360 divided by the 5 triangles. That would tell me the measure of angle 1. Remember, they're all the same measure, so we're going to do 360. Let me clear that again, try it again, divided by 5. That gives me 72 degrees. So that means angle 1 is 72 degrees. Now, I really don't care that much about finding angle 1. I am more interested in finding angle number 2. Angle number 2 is the one I probably will go right to when I do a problem, and I won't even care about angle 1 or angle 3 for that matter. Angle 2 is the one I want. So I'm going to let's think about this. This triangle, there are 2 of them for this side. So for every side, there are 2 of these triangles. So there's going to be double the number of angles, angle 2s, in here. So to do that, I'm going to actually take 360 divided by 2 times the number of sides. So the number of sides here is 5. I'm going to take 360 and divide it by 10, doubling the number of sides. That gives me 36 degrees. And that's the measure of angle 2. And that's going to become important when I do that problem in the next question. So 36 plus, it was half of 72. It's half of 1. So we could have just taken that in half. Last problem is question number 3, or the measure of angle number 3. Well, if that's 36 and that's 90, we can just take that from 180. And so I can basically just do 90 minus 36. And that gives me 54 degrees is the measure of angle 3. Okay, so that's the measures of the angles. But I'm more interested in finding the area of a regular polygon. So this one is a honeycomb made up of a regular hexagonal cells. The length of a side is 3 millimeters. So every side is 3. What's the area of the cell? I want to start with the formula. The formula is area equals 1/2 apothem times the perimeter. Well, the perimeter is pretty easy to find. There are 6 sides, and there are 3 measures, or 3 lengths for each side. So 6 times 3 is 18. So I have 1/2 times something times 18. The next question is, what is that something? What is that apothem? That is going to be from the center straight down. I call that A. And then I'm going to draw the radius to the corner. So I'm creating a right triangle. Okay? Now I need to know this measure. That was the measure of angle 2 in the previous problem. How do I do that? Well, it's going to be 360 divided by 2 times the number of sides. There are 6 sides here, so I divide 360 by 12. Let's do that. 360 divided by 12 gives me 30 degrees, and that's a good number. So there's a 30-degree angle there, making a 60-degree angle there. I have a 30, 60, 90 triangle, and let me blow that triangle up a little higher, a little bigger, so you can see it. This is the apothem. This is the 30-degree angle. This is the 60-degree angle. This is the 90-degree angle. And I do know one more piece of information. I know this length is half of 3. It's 1.5 millimeters. So now what I can do is I can actually find the measure of the apothem using what I know about special right triangles. This is a 30, 60, 90. The short leg times radical 3 is the long leg. So this is going to be 1.5 times radical 3. So the apothem is going to fit that right in here. I'm actually going to write as 3/2 radical 3, if that's okay, because I have a fraction here already. We can probably turn it into a decimal here in a minute. Okay, so If I do this, I've got 1/2 of, well, let's do 1/2 of 18. 1/2 of 18 is 9. So 9 times 3 over 2 radical 3. Let's find out what that is. 9 times 3 is 27. So that's going to equal 27 over 2 times radical 3. So that's one way to write the answer, and that's millimeters squared. Remember, it's an area formula. Okay, so we could write it that way. If you wanted to do 27 divided by 2, you could write 13.5 times radical 3 millimeters squared. You could do that. That would be acceptable. And then you could also just do 13.5 times radical 3 and turn it into a decimal, but this would be a rounded answer, 23.38. 23.38 millimeters squared. So these answers are all correct. I would say the top two are more correct than the last one because the last one's an approximation. But this is really how you're going to find the area of a regular polygon.